Nick, Dan, thanks for meeting with me this morning. Here at Forever Green, you know we deal with a lot of green solutions in the U.S. community and the global community as a whole. One of the major issues that we're facing right now is heat-tolerant crops. In the wake of climate change problems, mainly global warming, we see a lot of problems with our crops, and we need to find solutions for that. Nick, can you give us a little look into some of the technologies that we can use to assuage this problem?
Of course. Thanks for inviting us here, Joe.
No problem.
The molecular and biotechnological strategies that we are currently using are marker-assisted selection and genetic transformation. Marker-assisted selection selects for a certain allele that will cause a stress, and we are able to modify these genes once they are selected with genetic engineering so they can become resistant to, say, heat. And genetic transformation is taking a certain host DNA that is resistant to, say, heat, and we put it in a vector cell, and we take that cell and combine it with another host cell, so the host cell will replicate and produce more cells that will be resistant to the stress that we selected for.
Okay. That seems good, but Dan, can you go into what advancements have been made from these technologies?
Yes, thanks for noticing the advancements. The advances in genetic transformation and gene expression techniques have allowed greater understanding of the genetic and biochemical basis of plant stress tolerance. For instance, a noticeable progress has been made in the identification of genes, enzymes, and compounds on plant stress tolerance at the cellular level.
Okay. So what are some of the challenges that we're facing right now with this? And where is it going in the future? What can we do?
Sure. Transformation technology for improving plant stress tolerance is just starting its early stage of development. Many limitations in technology exist, and we still lack understanding of the processes that allow improvements of heat tolerance in various plant species. If we can gain knowledge of tolerance compounds and the identification and cloning of responsible genes in the future, it will help us to produce highly stressed tolerance transgenic plants.
So what you're saying is what we have now is a good base, and if we put money and efforts and research into creating better advancements on these technologies, we have a bright future.
Sure.
Sounds good. Nick, Dan, thanks for meeting with me today. We still have to go over it with the economic team and the PR team, but once I talk to them and we can get back together, we'll see what we can go with this. Thanks for coming, guys.
Thank you.
John, Nora, thanks for meeting with me today. I met with the scientific researchers earlier, and they were highlighting two new technologies that can be used in the heat-tolerant crop situation. What I need to know from you two is it worth for Forever Green to invest money into this strategies in these situations? John, can you highlight the economic standpoint and tell me what's going on?
Yeah, Joe, the economic impact is pretty straightforward. Crop economics doesn't work the same way as normal economics does in regard to supply and demand. When demand goes up, farmers actually end up planting more crops, which isn't the way it would normally work. So heat stress in that situation actually is beneficial and would help keep crop prices in check. But in climates such as Africa, which are much more volatile climates, where even 1 or 2 degrees can wipe out the entire crop for a season, development in heat stress crops would be enormously beneficial. And one area for economic return would be in GMOs, or genetically modified organisms. There's going to be a lot of investment opportunity for investors, and a lot of these companies are going to be able to provide a great return on investment. So there's definitely a lot of money to be made in heat stress crops.
Okay, sounds good. So from a money standpoint, what you're telling me is we can invest into these technologies as long as we're sure that we know how it will affect the economic standpoint of each community with which we're researching in. And it seems to me that in the U.S. as well as in other places like Africa, both can be beneficial.
Correct.
Okay. So Nora, can you tell me how it's actually going to affect society in terms of the people? What's going to happen?
Well, basically, I think that we will be happy with the technology that we have, because with the technology we have, we produce more foods, and more foods good for everyone, right?
Yeah.
Yeah. So, but the only concern that we have that the oversecurity in the society, because most of the GM food that we produce are corn and soybean.
Yes.
So these are the contributor for the processed food in the market. But if they overconsume this product, this is not good for their health. This will increase the obesity rate in the society.
Okay.
But on the other hand, for the farmers' point of view, just like John said, they'll be happy with it because they will get more subsidy if they grow this type of crops.
Okay.
So basically, I think there's a pro and cons in this thing.
Yeah.
And we should consider that properly.
Yeah. So basically, if I can sum up what you're saying, there are pros and cons to it, but we can look at what outweighs what. And I know there are communities where obesity is a problem, but I feel like in the third world countries where starvation is a problem, more fatty foods can actually be a benefit, maybe.
Yeah.
So I think it's something that we can look on both sides of the fence and see where's the best way to go with it.
Yeah.
So Noor, John, thanks for meeting with me. We're gonna mull this over. I'm gonna take it to the exec board and see what they think, and we'll decide whether we should invest. Thank you guys.
Thank you.